Please subscribe, like, and share. To start off this video, we'll look at how we can build efficiency in a low-cost package. Like we said earlier, I will show how I loosened up the oil control rings and freed up the engine quite a bit. And then at the same time, this one here is an 11.5 compression ratio 347 with cast iron GT40 heads. Now the GT40 heads don't flow as much as the AFRs and all the other small aftermarket heads. But the fact of the matter is, it's cast iron, it's able to retain the heat. And with the heat content, it will become very responsive with power. Remember, heat is power. Compression is heat. The higher the compression, the higher the heat. But if you have an aluminum head on 9:1 or street ratio 9:5, you're selling yourself short. If you have 11.5 cast iron, or even if it's aluminum with 11.5, you will have a responsive engine. Listen to this thing and let me know what you think.
This is the 347 stroker, 11.5 to 1 compression. Wow. That's 6,000 RPM. 6 grand? 7?
7,000 RPM. It's got a hydraulic roller, 230 at 50, 540, and sometimes we tried a 1.7 rocker in this thing, and you add 35 on that. It's more like a 575 lift. Very, very strong combination. Okay, 11.5, like I said, with the stock rods. I mean, not stock rod, but 5/400 length rod that comes stock with a 347 stroker. Okay, so let's proceed how I got there with this combination. Here we go again today, Street Tech. And by happenstance, when we modified the ring pack, it allows the engine to be vacuum pump ready. Okay, so when you try to evacuate it with a pan evacuation system or running a vacuum pump, this ring modification we will show here has the ability to adapt to a vacuum pump type engine. A lot of guys that I've seen through the years will hook up a vacuum pump and say, it didn't do nothing for us. Of course it won't, because the rings are too tight. The second ring won't allow the blow-by gas to be at the top, and second ring to be pulled through the oil control ring via the second ring gap, which is larger than the usual. What was said before was the ring gap is usually tighter than the top ring gap. Now it's the other way around. Even without a smog pump, a vacuum pump, I would loosen the second ring. Okay, we will show that here, what you do. And really, when you do that, even for a stock build, you're gonna gain a little bit there. But more so when you evacuate the block with 10, 12, 15 inches of vacuum in the crankcase, that will allow it. And by chance, if you do this and later on you want to put a vacuum pump, it's ready. But if you run it stock the way it is, and I'll show you the rotational mass and the rotational friction, it takes a lot more to turn the whole crankcase. Okay, we'll go through with that. Here you go. Follow on. Here we are on this one. Is even more obvious. This one has one ring, delete the second. This with a modified oil ring. This one here, the farther one, is complete first and second ring with a non-modified oil ring. Okay, look at how this one pulls. Like I said, I wish I had a fit scale but here it is. Okay, let's try that again. And here's a modified oil ring and just a top ring. If I can show that anymore. Here it is, as you can see. Top ring, modified oil control ring. Okay? And this one here, like I said, oh God. First, second, unmodified oil control ring. If that doesn't show you the rotational drag any more different, then do not attempt this. Okay? And I will go through why and when can we delete the second ring without any ill effects. Okay? Be good. Next segment. When do we know when it's time to try and take off the second ring? I wish I had one that just came out of the engine, but usually you have combustion residue on the top, above the top ring. If the second ring, the distance between the top and second ring is clear like this, there's no combustion residue getting past the top ring to the second ring and getting trapped by the second ring, you can try to eliminate the second ring for less drag. Okay? Because if there's hardly anything getting past the top ring, called blow by to this area on the second, about the second ring, and there is no blow by, then what is this doing? But remember, the second ring is a oil control ring. It is not a compression ring. Therefore, when it's very clear, go ahead and do it. That is a quick way of evaluating if you can get away with it. But if you took the pistons out of the engine, let's say it was running, and you have a combustion, you can see like discoloration here, very dark discoloration, then that means you got issues with the top control ring, trying to retain the compression. Then taking off the second ring might not help you at all. But if it's this clean, and I've seen it just like that, well, all bets are off. Try it. Okay? So that's one trick. And like I showed you on this video, what is the ring drag and how significant it is to the whole rotational resistance to the engine. Okay? Okay, now what we have here is the modified oil ring on this one and the standard oil ring unmodified on this side. When you look at it closely, I wish I had a fish scale that I can push or pull and see how much weight there is. But if I grab it here, okay, that's how much tension this one has. Now you look at the modified oil ring, that's how I could pretty much say or show how light it got. Again, that much heavier. All right, that much heavier. And this one here, so much light. Here it is. Okay, just the oil ring. And what I have here, I will show you how I modified that thing. Okay, let me look at this. And well, a little bit of oil here, kind of slippery. Here's what I did, so you can see the ends right here I bent that one there. Okay, and let me pull this one. Let's see how it looks like to you guys. Even pulling it, you can see how hard it is. So you could see that it's got WD-40 in there, so I don't scratch the cylinder wall. See the ends right there? Okay, I haven't bent this one yet. All right, whereas this one, you can decrease the tension some more by bending that some more, a little bit farther back. So there you go. You can see both sides, how the ends are bent. Okay? Here we go. This oil control ring is modified this way, okay? The ends here come in this configuration. And what we're going to do is we'll bend the corners flat like this so they sit flush, okay? And that will reduce the tension. And it's kind of hard doing this because I usually do this by hand without looking at the camera. Okay, notice that right now that is now straight. One side is vertical. Okay, now we'll do the other side. Slowly again, have patience. Remember, this is spring steel, so it snaps back to its old position. Okay, now there you go. Now there you go. Now you see it. Now they're flush. Okay, it's not an A configuration anymore. And what it does is it brings them closer to each other, reducing the radial tension of the oil control ring. Okay guys, I hope that's clear. Whereas this one, after I bent it, it's flush side to side. Okay, the V tension there creates a lot of spring outward pressure. That's why it drags on the cylinder work quite a bit more. I have seen many incidents and times that people put in a vacuum pump or some kind of pan evacuation system and they said it didn't work. Well, one of the reasons it didn't work was they did not mess around with their ring package. You cannot just put on a vacuum pump and think it's going to work fine. And let me explain why. Okay? You need to mess around with your oil control ring and perhaps loosen the second ring gap. Now, what actually happens when it runs, okay? A certain amount of blow-by, depends on the engine, gets between the cylinder area here, the combustion chamber, past the top ring to the second ring. Space between the top and second ring. There is some pressure trapped in here. When you use the old school thought or process of setting the top ring, let's say 18 and the second ring 14, you're gonna trap these gases right here. Okay? And when it traps it, any sort of vacuum you have below the crankcase to try to pull that trap blow-by gas between the top and second ring is inhibited or prevented by the second ring gap. So what I have said all along and what people have found out was that when you set the second ring the same gap or maybe a little looser than the top ring, let's say the top ring is 18 and you have this at 20, they see gains of power. Okay? The reasoning is when you also loosen your top ring tension by messing around with this rail like I showed earlier, when you have blow-by gases gets between the top ring and the second ring, it creates pressure here. When the pressure is built up and you have a looser oil control ring or a thinner oil control ring and a wider second oil control ring end gap, any sort of vacuum here, 10, 11, 12 inches, will easily pull it past the gap through the looser oil control ring and into the crankcase and out through your valve covers, through your breather, and exhaust it out. That is how it functions. Now, conventionally speaking, if this was a tight 14 instead of, let's say, 18 or 20 from an 18 top, and let's say this is 14, when it gets past the top ring, it starts building up pressure here from successive combustion and ignition cycles. The pressure builds up, okay? And when you have the compression cycle, ignition cycle, and exhaust cycle, this crevice area here, it cannot exhaust out. It cannot go to the exhaust port. It's trapped by the top ring. And also the pressure stays constant here, or almost constant, high pressure. On the intake stroke, you have low pressure here, or like they say, vacuum in automotive, and you have high pressure here. Guess what it does? Differential in pressure, it wants to unseat this ring, or what they call ring flutter. It'll push, and now you have EGR action on top of the combustion chamber. Not good at all. So this pressure buildup, and then is there, and then the oil ring is not modified in any way tension-wise, this pressure cannot go down to the crankcase by pulling of a vacuum pump or pan evacuation system. It is trapped. You guys get it? So you should find ways to allow it by a bigger ring and gap and a lower tension oil control ring by messing around with the spring here, cutting it or bending it, or altogether using a low tension oil control ring. You cannot, I repeat, you cannot successfully use and evacuate your crankcase with a stock ring arrangement. These are all stock, but opening it up and all the adjustments done will give you what you're looking for. That's why when people say, oh, it didn't work for me. Of course, I've seen that happen. Oh, it didn't work for me because you did this without the proper knowledge of what's going on. You just did it because you want to do it. You put it on. Just like one guy says to me before, oh, we switched to alcohol. We didn't gain anything. Yeah, because your compressor's goddamn too low. And the heat content of alcohol, it even make it worse. Okay? When you have the heat content due to compression, then alcohol fuel would be really, really nice. It's a cooler fuel. It doesn't have the heat or BTU content. So you got to give it some kind of mechanical compression in order to work. Same thing with the vacuum pump here in reverse. You got to give it a pathway to get evacuated. Without the pathway, you have nothing. And I've seen this repeatedly over and over. Okay, guys? Now, when you took off the second ring with a vacuum pump, wow. And you utilize this you loosened up your oil control ring. When it gets past that, guess what? The path for the vacuum below here, be it 12 inches, 15 inches, 16 inches, it pulls that rather easily, real quick. It'll put it through this area here, below the top ring. And you can easily clean that up. And your succeeding intake portion or intake cycle, there's no high pressure from below here to coming up and contaminate your fresh air and fuel charge from the spent gases trapped between the top and second ring from previous ignition cycles. Okay, guys, I hope that's clear. Now you're looking at the two rings as it came from the block. If you notice, the stock ring it's got a V separation there between the rails, whereas this one, after I bent it, it's flush side to side. Okay, the V tension there creates a lot of spring outward pressure. That's why it drags on the cylinder work quite a bit more. Now we're talking about also the accumulator groove. All the combustion gases that get past the top ring has a lot of space here. Okay, this accumulator groove is like an expansion area for the blow-by gases so as not to unseat the top ring. That's there by design, which is pretty excellent. But the only problem with this ring pack, it's real far apart from each other. Presence here, you don't see any discoloration. Sure, you can take up the top ring, but now we're going to look at another scenario. This is a Holley piston, good quality. Now if you notice, there's an accumulator groove that is very, very tight. It only has a little thin line across and a smaller 043 ring pack and a small oil control ring design compared to that one there. This one would lend itself good to a vacuum pump. Okay, so a lot of these things happens by accident. When you loosen up your oil rings, your vacuum pump is going to work real good. So a lot of you guys probably running this piston, and by the time you put the ring land in there, the vacuum pump, and it works for you, you're lucked out because it was partially into the design by accident. Okay, that it's work out good for you. But the accumulator groove is quite small. That's substantial. This is very small, and so the pressure buildup on the second ring gets up there real quick because the distance between the top and second ring is about half, and you don't have a deep V groove because sometimes the V groove weakens the ring land. That's why they keep it thick right there, and just a little groove. Hopefully, you got a vacuum pump in it. All right, and here is the oil control ring, goes to the top ring. Do not concern yourself with so-called oil consumption. That's just a fallacy. All right? If you have the right tension, you're not going to have any oil consumption. I hope this video came up pretty clear. I wish I had two exact duplicate engines where I could rotate it in front of you guys. How much torque it takes to rotate these engines, if it's 347 or 302. And what comes up absolutely clear is that by the time you do this modification, if you have a stock block in there, you try to put a torque wrench in there, a digital torque wrench, and try to see how much rotational drag torque-wise does it take before it starts rotating. You'll see the stock factory blocks Ford, I've seen them, and they go between 35, 45 foot-pounds of torque to rotate them before they start turning. That's quite significant. This configuration with the kit block pistons here, which is really a stock replacement because they're hypertectic, and the factory pistons are also hypertectic, especially with the 5.0s after 1989, 1990, they became hypertectic instead of forged. Now, with that said, when you do this modification, you will see that it will turn perhaps about 11 to 12 foot-pounds of torque. A lot also depends on the bore finish, but that's pretty much representative when you mess around with the oil control ring and delete the second ring. 12, 11 foot-pounds compared to 35 on a used tired block. And I've seen some, and you guys seen this, when you rotate a stock block and you're going, wow, that's heavy when you're turning it. Think about if that's 45 pounds. Now you're turning it with mere 11, 12 foot-pounds of torque. That's a gain of what? Quite a bit, right? 25, 24 foot-pounds of torque. That's big, rotational-wise. It's so much easier to start even with a little higher compression than normal, which I always tell everybody run higher than normal. What everybody's running 9.5, 9 to 1. Wow, what a waste of time. Now, this even gives you more of a reason to build your engine, your street engine, to 10.5 minimum, 11.5. Now, if you guys are good, you play around with your lobe centers, the camshaft, you can get by with 12.5 on pump gas, especially if you get a light car. Now, the other piston I showed is like this Molly. Same thing, the offering from Diamond, Ross pistons, 043 with a 2mm oil control ring. Significant, okay? On a 408 stroker or 426, 432, depends, a larger stroker, 351 or even a 347, I go down as low as 6.5 for a 347 to 7.5 with a 408 with this kind of pistons, because they already have a thinner ring, less drag, especially if they have a Napier second ring. The Napier second ring is like 043, but in actuality the area that's touching the bore is a lot less than that, okay? It's got a step, and that little step is the one that's touching the cylinder wall, and everything else is freed up, especially when you run low tension oil rings, or if you specify an oil ring pack if you're using a vacuum pump on your engine or a pan evacuation system. It is all worth it. Like I said, you know, a lot of these guys have run combinations such as these. Oh, the vacuum pump didn't work. Yeah, because your oil ring is too tight. Okay, so that's all we have for today. Take it easy, guys, and please subscribe, like, and share my videos here on YouTube so we keep this going. Thank you. Please subscribe, like, and share.